Good morning, everyone. I am Vinita, working as an associate professor in the Department of Electrical and Electronics Engineering, RMD Engineering College. Today I am going to discuss about arc suppression coil grounding, or otherwise called as resonant grounding. So as we have discussed in the resistance grounding, we have seen that in order to reduce arc suppression, we need to provide earthing. So here in this case actually, and a reactance which is connected between the neutral as well as the ground. So by providing this reactance, we can able to eliminate the arcing grounds. So that's why we are going for adding the reactance between neutral as well as grounding. In this three-phase system, we have R, Y, and B three phases are there. And let us assume the fault has been occurred at phase B. And here this F represents the fault point. So during this faulty condition, the fault current from R and Y that will be flows through this faulted point, because this faulty point that will be acting as a least resistance path. Therefore, all the three currents, that is the current from R, IR, or current from Y phase, IY, and then the faulty current IF from the same phase B, all the three currents that will be flowing through this faulted point. Now, this faulty current IF that will be flowing through this arc suppression coil, and then the remaining two currents IR and IY that will be flowing through their corresponding capacitances CR and CY. Therefore, this magnitude of current IF that will be equal to the magnitude of current IR plus IY. Therefore, the arcing currents can be eliminated because these two currents are same in magnitude, at the same time both are in opposite direction. Suppose if these two currents are not same, then by adjusting this arc suppression coil, we can able to adjust the current such that IF is equal to IR plus IY. For that only here in this arc suppression coil, number of tappings will be provided. So by adjusting these tappings, we can able to adjust the currents, and so that we can able to maintain IF is equal to IR plus IY. And with respect to these conditions, we need to draw the phasor diagram to satisfy all these conditions. So first we can draw IC is equal to IR plus IY. Like resistance switching, here also same phasor diagram. That is, we need to first draw three vectors, VR, Vy, and Vb. So this is Vrn, this is Vyn, and this is Vbn. And we require the line voltages VBR as well as VBY. And the corresponding line currents are IRB and IBY. Since for star connection, line currents is equal to phase currents. Here it is represented as IR and IY. Now first we can draw the current IR. So here, where is VR? This is VR vector. So for this VR vector, if you draw 90 degrees leading, because this is nothing but an capacitive current. So this current IR that leads their corresponding voltage vector VR by an angle of 90 degrees. Similarly, here we have Vy vector. For this Y vector, if you draw 90 degrees leading from R, we will be getting IY vector. And if we join these two vectors, we will be getting the resultant current vector IC. That is the vector sum of IR and IC that gives IC. Now we have drawn the current vector IC. Now we need to represent the faulty current vector IF. So from this diagram, we can say that the faulty current IF is purely an inductive current. So obviously this IF current that lag behind their corresponding voltage by an angle of 90 degrees. So here, where is this VB vector? This is nothing but an VR, Vy and VB vector. For this VB vector, this current that is lagging, because here this is the vector that will be rotated in anti-clockwise direction. So this voltage VR is leading, VB is leading, and its corresponding current IF is lagging. So we can say that this IF and IC both are in phase opposition. That is, the magnitudes of both the currents are same. At the same time, these two currents are in phase opposition. So IF which cancels IC, therefore we can eliminate the arcing grounds. This is the main objective of providing this arc suppression coil. Now, this is the circuit diagram for this exact arc suppression coil. So this is a three-phase alternator circuit, and here we have an current transformer, and this is arc suppression coil, which will have number of tappings, and this is an relay circuit. So this arc suppression coil, which will have number of tappings. So by adjusting this number of tappings, we can able to set the condition IF equal to IC. IF is equal to IC. This is about this resonant grounding. And in this resonant grounding, we can derive the expression for L. That is, at what value of L if we adjust, and so that we can get the condition for IF is equal to IC. And we know that IR is equal to IY is equal to root 3 into V phase divided by XC. And IC is equal to root 3 into IR. From this expression, we can write root 3 into IR is equal to root 3 V phase divided by XC. Therefore, we can write root 3 into root 3 is nothing but 3. Therefore, 3 into VPH divided by XC, where XC is the line to ground capacitive reactance. And from the circuit, we can write the fault current IF is equal to V phase divided by XL, because the fault current which is produced only due to the reactive circuit. Now, for the resonant grounding, we can write IL is equal to IC. So we can substitute the values for IL and IC here. IL is equal to V phase divided by XL, and IC is equal to 3 into V phase divided by XC. And therefore, from this we can write XL is equal to XC divided by 3. So we know XL is equal to omega L and XC is equal to 1 by omega C. Therefore, this expression can be rewritten as L is equal to 1 by 3 omega square C. So this is the value of L at which the resonant coil is adjusted, so that we can get the condition IF is equal to IC. Now, this resonant grounding, which is otherwise called as Peterson coil also. So let us see the advantages of this Peterson coil. By means of providing this Peterson coil, we can completely avoid the arcing ground. And this Peterson coil has the advantages of ungrounded neutral system also. And let us see the disadvantages. Due to varying operational conditions, the capacitance of the network changes from time to time. Therefore, inductance of Peterson coil requires readjustment. And here the lines should be transposed. So these are all some of the advantages and disadvantages of arc suppression coil. Thank you.